So let's look at an example. We want to find inverse of 101 in modulo 4620 arithmetic. So what we are going to do is, first we are going to check that their GCD is 1. Then we are going to find S and T such that S times 101 plus T times 4620 is equal to 1. How do we do this in general? Now, to do this in general, I want you to review earlier slides, but I want to sort of give a brief summary of what we were doing. But what we were doing was we said 4620 is equal to something times 101 plus something. We filled in the quotient, we filled in the remainder. Then we wrote this remainder in terms of the original two numbers. Then we continued further. We took 101 and this remainder, continued that process. The new remainder that we got, we rewrote in terms of 101 and 4620. And we continued this until we stopped, at which point we would have found the GCD and we would have rewritten the GCD in terms of its specified coefficients. In this example, I'm going to ask you to take my word for it that we can get S is equal to 1601 and T is equal to minus 35. Now, one of the things we want for our cryptography purposes is we want S to be always positive. One of the things I'm going to ask you to think is, what should you do if S turns out to be negative in your calculation? There is a way you can fix it, but I would ask you to think about what you can do, and if you're not able to figure it out, this is something I would like to discuss in class. If you are able to figure it out, I would like you to post this on Piazza, because this is something that would be helpful to you as well as to other people in the class. The thing that you have to do is fairly straightforward. Think more like multiple of 101 and 4620 and see what you can do with that. So now that we have found S is going to be our inverse. So 1601 is the inverse of 101 in modulo 4620 arithmetic. We can check our answer by multiplying it, taking the remainder with 4620 and checking that it is indeed 1. So let's look at this problem. Find Q such that 101 times Q mod 4620 is equal to 5. Now we're going to use what we did on the previous slide. What we did on the previous slide was we had found the inverse of 101 in modulo 4620 arithmetic, and that was 1601. So we had 1601 times 101 was 1 in modulo 4620. We're going to multiply by 5 on both sides. Then we're going to group these together. 1601 times 5 will be 8005. Now, because 8005 and 3385 are congruent in modulo 4620 arithmetic, then that basically means 8805 mod 4620 is 3385, and that means 3385 times 101 is 5 in 4620 mod arithmetic. That means the value of Q that we are looking at is 3385. You can check it out by making sure that 3385 times 101 mod 4620 is 5.